Greetings. Euclid's solution to the equation x squared minus ax is equal to b squared. This particular problem is rather interesting in the fact, let's think about what it's saying. We're looking for an unknown number that I can create a square out of. So I'm not going to have any idea how big this square is. The only thing I know is that on this square, I'm going to mark off a distance a. That way, when I cut off this rectangle, a by x, it's going to leave me a rectangle. And this rectangle must be equal to a square of known size. So the only thing I know is how wide the rectangle I'm going to rip off is and how big the final square is. The question is, can I find this number, this unknown, to make the square in the first place? This is a very interesting problem in the fact that now we see it's really kind of well, it's daunting. Let's see what Euclid did with it. And now, since we have a clean board, we're back. So let's begin. Well, obviously I can't begin with a because I need to begin with something that tells me about my square. But a does tell me something about my square, so let's take a look. So I'm going to represent a, which is a copy of my a up here. Now then, I need to put b somewhere. Let's take a look at where we're going to mount b. And again, I'm standing b up at the end of a because I'm going to be adding a little piece on to the end of this. All right, so now we've seen two problems by the time you watch this video where I stand b up at the end of a because I'm adding something to a known value. If you notice, if you go back to the very first video, we stood b up on the midpoint because we were cutting off a piece off of a times x. So keep that in the back of your mind as you watch the remainder of this. Now then, we're going to do the same thing we did earlier. We're now going to find the midpoint of a, and we're going to go find our unknown. Now this problem right now looks a lot like the previous construction. I now know what x is. But in the previous construction, x was this little piece right here. That's not the case this time. Remember I told you we were trying to find a big square that we were going to rip a rectangle out of? This distance right here is x, all of a, and this piece right here. So when we look to construct the square of our unknown, there it is. And I've shaded it in two colors so that we can see the relationship. This blue square, or sorry, blue rectangle to the side, is the rectangle that is provided to me by saying, hey, this piece right here is a, and it's x up and down. So this blue rectangle is a times x. This whole square, the blue and the green together, is x squared. So the question is, does this green rectangle actually equal to the square we were given on B? And then the question is, have I done the only solution that'll ever work, or can I play with this and keep it working? Let's take a look at the measurements. So what I'm going to do is I'm going to measure three pieces all at the same time. And I'll drag them down here, and we'll take a look. And I'm pretty sure this big number right here must be a times x. So this one right here, h, g, k, and I, well, that has to be the green bit. And let's see, L, what is it? L, H, M, and N, this is the purple bit up here, and they have the same number. And no matter how I change the size of B, these numbers stay the same. Likewise, if I change A, these numbers stay the same. Now please forgive me, my construction falls apart because of the way I made it. But it would still work even if this square stuck out here over to the side. So with this in mind, hey, fear not, we have a solution to our equation. We found a huge square, And from this square, we cut a rectangle off, and we had things being equal. Now, two of these problems that we've done with quadratic equations are related to one another. I wonder which two they are. More on that later. I hope this helps.